Okay, today I'm going to look at sort of another widget which comes in useful for uh, certain things. Another, it's one that it doesn't fire action events. I wish it would, but it doesn't. It fires something else called change events, which I mean, in a way, sort of makes sense. The different anyway, so it's called a JSlider, and you're familiar with that particular little piece of things. You know, in other words, like if you ever used like a media player, you know, and you want to adjust the volume, or you want to actually, or you're watching a video and you want to kind of scroll to a different place, that's basically what this thing is. And then look at loading an image file and kind of displaying images, so we can kind of make our applications look a little bit nicer, or you know, maybe the image itself is part of what we're trying to do. So if you have like, say if you have a simulation and you want to show an animation of the units running around, then you know it's nice to have like kind of a map as the background. So what is that map going to be? It's going to be typically an image file, so some kind of image file. There are fancier, scalar vector graphics and all that sort of stuff, which is not supported at this level, but kind of at another level. But that's a little beyond what we're doing here. And then just as a use case for this JSlider thing, we're going to use it to modify the size of the image, you know, kind of make it bigger and smaller, just, you know, that's. Okay, so the code examples should, you know, show you, you know, basically how to do it, how to manipulate another object. It uses this listener pattern to do it. We've seen two listener patterns so far. We've seen the window listener, which we use to ask the user to confirm that they wanted to exit something. We've seen the action listener, which responds to, to buttons, and also we saw it respond to the combo box. You know, so whenever the user manipulates something and it's changed, then an action event gets fired. Again, it would be nice if the slider also fired an action event. There's no reason it doesn't. And actually, in kind of when you look at kind of what it does, you can see that it was actually one of the early widgets that they had, and for some reason they used an older form of the they used something called a hash table instead of a hash map that we like here. They may have a reason for it, but in fact, if you look at the comments in the Java doc, they say it'd be better to use a hash map, but they didn't, you know. So, you know, and the thing is that as I mentioned at the beginning of the class, you know, Java was originally appealing to the idea of something small and simple. It was in reaction to C++, which at the time was the dominant object-oriented language, which was large, complex, difficult. It's gotten a little easier, but it's still pretty complex. Like I don't know if you've ever programmed in C++, bless you. Going from Java to C++ is a bit of a challenge, because things that are easy to do in Java are difficult to do in C++. Going from C++ to Java is like swinging a leaded bat and just kind of going at your at-bat. It's my experience is that people who who have done C++ programming can adopt to Java very quickly, and they discover that things that used to be difficult are a lot easier. So all that to say that Java was, see, when it came out, this was very true. It was small, it was simple, and there were things about it that people kept, basically it was sort of, feature creep doesn't quite describe it. It's kind of feature tsunami is kind of more like it. The core language itself is still relatively small and simple, but in order to really do stuff, you need the standard class library, which is available. Almost everything that we've been using has been in the standard class library, like the swing components that we're using here. But again, this feature tsunami has just made things so big that it's hard to kind of wrap your head around the whole thing. As back in the day, I think I might have shared this, is that my objective was to kind of learn every piece of the language, including the class library. And if they hadn't, if they kind of stuck with the original Java, I could have done that. But the problem is they kept sort of adding stuff faster than I could assimilate it. So I finally gave up on that. And you can kind of see that some of the critiques that I've made of the book have been situations where the author of the book was kind of doing things in a certain way, and then what happened is that Java developed a better way to do it, but he didn't pick up on that. And that's true of some of the things that I do as well. So there's always kind of a little more, I'm always kind of picking up more better ways to kind of do stuff. This is an example here. Like I haven't kind of pointed you to place the, you can kind of look up in the book where the author talks about images. The problem is that he does it in a very low-level way. What's the low-level way? They kind of, under the hood, what is an image file? An image file is, just a bunch of bits, just like everything else. And so the way that we had to do it back in the day was to actually access it at the byte level. So typically we had to open up an input stream and then read the bytes and then take those bytes, and then if it was a large file, we had to kind of use a buffer. In other words, instead of trying to gulp in the whole thing, typically kind of slurp them in about either 1024 at a time or 2048 at a time, and kind of do it that way. What's the issue with that? Well, the thing is that when we are programming in Java, we are at a high level. Object-oriented design is a high level of abstraction. And if you're in a situation where you're working with bytes, that's kind of way too close to the bare metal in terms of what we're doing. Another thing that Java supports that we haven't talked about is bit manipulation. So every variable in Java is a word, but it's a bunch of bits. And every number can be manipulated by shifting its bits around. That's doing bit level manipulations like ands and ors and nots and XORs, etc. So why don't we talk about that in the class here? Well, because if you're if working at the byte level is way too low level, working at the bit level is ridiculously low level. So I mean, if you're manipulating bits, then Java is probably not the best language of choice. If you're manipulating bits, you should be programming in C, not C++, C. Why? Because C is kind of between the high. C sort of talks to the bare metal. In fact, most of Java is written in C. the class libraries are written in Java, but it's like the core language itself is in C. So just, so I mean, if you're writing a language, don't write it in Java, write it in C. So, or some other, anyway, so all that to say that as you'll see, there are kind of higher level ways of slurping in these images. Okay, so the slider. What is the slider? The slider is, well, what it kind of describes is that it's this little, thing. Should look fairly familiar. It's got in this case, it's horizontal. You can configure it to be vertical as well if you like that kind of thing. But it's got a little scale here. It's got a certain length, and it's got a little nib here. And what do? You grab the nib and you kind of move it back and forth, and it goes to different values. So actually, the default values are 0 to 100, which I was using here. But you can set it to any values that you want. So the 0 to 100 is the default, but you can set that by the user. When the user manipulates, it fires a change event. And it, if I had my druthers, it would fire an action event, because why is an action event nice? Because almost every other widget does fire an action event. So what you can do, therefore, is that if you have an action listener, then it can be somewhat indifferent to what widget is being manipulated. So the same listener can basically do the same thing even as if it's been manipulated by different places. We've seen that before in situations where there's either a menu item or a button, and the same code gets executed either way. And that is in line with the principle of one place of code. If you're doing a task, the optimal number of places that you have that code is 1. Okay, so change listener. So what is here? Okay, so let's see what we can do with that. And now for these two, the two examples that I'm giving you are, in a way, they violate another principle, which is ideally you have two types of classes that we've talked about here. One are components, which are reusable, and the other is sort of the main method, which is disposable. In other words, an example of this actually is, if you remember, we did this window closer thing that was a dessert topping and a floor wax. It was a window listener, an action listener, and what does it do? It says, hey, do you really want to exit? And notice that's a separate class, which means it's a component, and one of the nice things about that is that having written that once, we can use it any time we have a JFrame and we want to confirm the exit, then we just reuse that. So that's a component is reusable. A main is used once. So the principle is that ideally components you want to keep separate. Now, for a classroom example, the whole thing is kind of a throwaway. So it's just a way of illustrating the code. So therefore, in this example, I've actually, there is a main method as well as the component. They're kind of bolted together. So while this isn't a good design for production work, for classroom thing, the trade-off is your code just sort of gets littered with a whole bunch of these throwaway things. So anyway, so that was kind of a choice, but just understand that I'm not, the principle still stands. Ideally, you want components to be reusable. Okay, so so what we're kind of doing is that's sort of creating this thing here. So let's see what we have. So we're extending the J-frame, and now I have two instance variables here. If you notice sort of in the way it's sort of laid out, there are two components. This is the slider thing here, and then this is going to be just a label that's going to display the value. That's really all it is. So to do that, especially because we're going to be using a listener, which is going to be an inner class, the listener needs access to both the slider and to the label. And so because it needs access to that, they need to be instance variables. So remember the principle of minimal scope is that ideally, variables in general should have the smallest scope possible. I mean, that's why global variables are really a mortal sin. And you may be thinking, well, what about these sort of these public static things that run around? Those are, strictly speaking, not global variables. They're actually global constants, because when you make them final and public, then they're not variable. So they're really a constant. There's nothing wrong with a constant. There's something, a global variable is evil because it can be changed anywhere. And so if that value changes, then it's like it literally can be anywhere. That's why the principle of encapsulation says that variables need to be protected because they're a little fragile. Okay, so so we're again we're going to be reusing the little window closer thing. So we set our default close operation to do nothing, and then just kind of having a separate initialize method here. So here I set up the window closer. Very straightforward. Okay, so we're going to put the slider in a JPanel, and we're going to put it up north. All right, so let's kind of build it. So here we instantiate our JSlider, and we add it to the panel. Straightforward for that. Now, this is sort of a little funky here, but one convenient method they have is something called create standard labels. And what that does is that says the standard labels, you give it an increment, and this will, oh drat. I better go plug in. Excuse me. I'm gonna pause. Where are you? Okay, so yeah, so the slider has a an instance method that creates the standard, which says create standard labels, and what you do is you give it an increment. So in this case, I gave it 20, and what that did was that produced, it sort of first labels the minimum, and then it added 20 to each one. If I well, we'll see what happens if we change that. Okay, so then, and then I say, okay, I need to tell it to paint the labels. If I don't do that, then it'll create the labels, but it won't show them. You can create tick marks as well, and you can set it up so that it only gives the, again, don't want to necessarily get into that. I wanted to make the font a little bigger, so I did it there. Okay, so now, in order to update, I need a listener. So the change listener is the one that that can listen to these change events. And it has a single method called state changed. And then when I hear the state changed, I'm simply going to set the text of the slider value label to the value of the slider. So the get value of the slider tells me what value it's at. So here, instantiate the listener, and then I add it to the J slider. Okay, so now to set up the value label, I instantiate the label. Now the defaults kind of, I think the default was on the left, and I didn't like that. I wanted it in the center. So remember, in J labels, I can set the horizontal alignment. And then in this case, I wanted to set the vertical alignment to the top. So, they have center, right, left, and then for the vertical alignment, we have top. Let's see, what are some of the, let's sort of see. Top, they have bottom, center. So those are the possibilities. And then I wanted a nice big font for that. And then I added to the center. And remember, for the border layout, I added the slider to the north, and I added the label to the center, so that when we run this, okay, so, and it's, by default, it starts at the midpoint. You can change that. But then now, when we kind of move the thing, what this is doing is this is, just as I move the thing, it just sort of changes this. How's it doing that? It's doing that right here for the state changed. So all it's doing is just updating the value of the thing. Okay, so that's the J slider. Now with images, working with images is very, we could spend a whole lot of time just on that, manipulating images. There's lots of stuff that one can do. But here the main objective is situations where you want to have, you might want to add images just to kind of make your application look a little nicer. You may also want to have like icons on the buttons instead of just the words, so that's, and so in that case we have to deal with images. And there are a whole bunch of classes to deal with, but the image class, there's the buffered image, which is a subset of that, and that's an example where if we only deal with sort of images, then for very large images, if you try to sort of suck in all the bits at once, then that usually is not the way to go. Typical way and this is true when you're reading large amounts of data, is that you don't want to try to read it all at once. You read it in chunks, and that's whenever you see sort of the buffer. Yeah, you're familiar with that idea, right? No? Okay. So a buffered image does it under the hood for you. So back in the day, if we only had images, then we had to do the buffering by hand. The buffered image does it for you. And then it turns out that the J labels that we want to put these in, for whatever reason, they don't want an image, they want an icon. So what's the difference between an image and an icon? I'm not entirely sure. But icon is actually an interface, and there's a concrete class that implements the icon interface called image icon. And what that does is that when you have an image, you can kind of instantiate an image icon, passing it the image, and it will create an icon with using the image that you just gave it. And then this is Image IO. This is one of the more recent classes that basically does all the heavy lifting for you under the hood. And we'll kind of see what's on that. So what we're trying to do here was we're trying to read an image file and display it. Now, there are a bazillion formats. Java supports the 5 most popular ones: JPEG, PNG, bitmap, GIF, or is it GIF? Do you say GIF or GIF? Some people say GIF. I don't know. I don't know. Anyway, so if you have one of those formats, then you're in business, and pretty much every image is kind of like that. These days, a lot of times, when you get an image from the web, there's like a WebP format that, as far as I can tell, is not yet supported, but it's easy to convert those into one into the other. Okay, so this image IO, again, if you're really interested in kind of what in the Sausage Factory, the book kind of leads you through reading in the bytes and stuff like that. But as I was saying earlier, at a high level, we don't want to, if you're dealing with bytes, then that's usually way too low level. So, Image IO has a static method called read, and it returns a buffered image. So it does the buffering for you under the hood. It can read a file, which is what we're going to do here. It can read an input stream, and what's nice about that is that we can get an input stream from almost anywhere. So you can get it from a file, you can get it from a road, or we can read it from a URL. So if we have a URL and that in fact points to an image on the web somewhere, then we can just basically slurp it down and use that image as we, thing. So buffered image, it recognizes the supported formats. Okay, remember, like an image file is still just a bunch of bytes, and when you're reading, everything that displays one of these things has to do a lot of work under the hood. I mean, it has to. There are typically bits at the front end that kind of identifies what it is and tells it, information about, okay, how many bytes are there in this thing, how, et cetera, et cetera. All of that is something that the people who kind of write applications that display images or classes that do images like the ones in Java here, that's just, again, that's should not be our job. So now once you get one of these things, kind of how do you, there are a couple ways of displaying it. You can kind of you can use it to set the background on things. That requires usually a little bit of extra programming and dealing with painting graphics and stuff like that. Rather than doing that, the easier way is to simply instantiate a J label and then stick an image in it, and then you can actually, the J label can take an image. It doesn't have to be text, and so we can kind of get our image icon from the buffered image. And so let's see what that's about. Okay, this is, what is it called? Rescale image is the class. Well, here, let's show you what it does. Okay, so we have an image here. And down here we actually have, here's the slider value. We're kind of displaying it here just for extra information. And here's our slider. So our slider actually goes from 0 to 200, so that it wasn't the default, that had to be set. And so what does this thing do? Well, as we move the slider down, what it does is it rescales the image. And if we want to make it bigger, we can kind of make it bigger. So now, little thing is, if we kind of anticipating this, if you remember, when we had text that was too big to display, we put it in a J scroll frame. So we can do the same thing with the J label. So we can kind of see what's going on here. And this is a fairly, I'm not sure how, as you can see, it's gotten a little pixelated. See, if we basically doubled the size, it's a little pixelated. That's still a pretty good image. The other thing is that the just a couple other little things on this. We can we don't have to actually by default it responds to mouse clicks. So if I want it to be here, I can just sort of click it and it'll kind of move down there. Comes out of the hood. And then the other thing is that in this case I added a tooltip. Yeah, what's a tooltip? So if you hover on something and all of a sudden a little pop-up comes up and it says what it is, and that doesn't happen by default or by accident, but here it just says scale image. Okay, so how did we do that? Well, again, we have a J-frame. Again, as a class exercise, we're just, I have the main method in here as well. So we have the slider and the status label, and then here's the image icon, and then the image label, which was the image label is that thing right. Yeah, the image label is the thing which is displaying the image. So all right, so let's see what we do on that. Okay, as usual, we set our do nothing on close, and we have the init, and then we're using our window closer to verify that we want to close. Okay, so here's here we set our J slider. In this case, I went from 0 to 200 instead of why? Because well, here the midpoint would be at 100, and 100 would be 100%. So in other words, that would just be the image with no scaling. And I put it up north again as before. So I'm painting the labels, and now I'm creating the standard labels with 20. Oh yeah, and the other one I didn't show you what happened when we changed that. So I remember to show. Okay, so here's where I set. Most of the widgets have a method called set tooltip text. And so here's where I did that. So that's what created this. And then the default size was a little bit on the small side, so I kind of I stretched it out a little bit more. So I set the preferred size, and here I have to use a class called dimension. So I want it 400 pixels wide and 50 pixels deep. And as before, I have a change listener, which I'm going to add. And then okay, so the status label, that's this thing down here. So I just sort of set the font to be 16 point sans serif plain. You can set the fonts to almost anything that's on your computer. Maybe we'll kind of show what that's about. You can actually list the fonts that are on the computer. So the font class is fairly smart about that. Okay, so that's the status label. So here's the heavy lifting. So the image label is a J label, and I wanted to set the horizontal alignment to the center because when I didn't do that, it was kind of shoved over to the right, and I didn't like that. In other words, when I rescale down, so you notice how it's going to the center. If I left it at the default, it would scale down, but to the right. I want it to be the center. That's how I fix that. Okay, so I add it to the content pane. Again, for some reason, I don't know why the book does it. The book was adding stuff directly to the JFrame. You can do that, but you shouldn't. Always only put stuff in the content pane. Okay, so here's actually the JPEG file that I got was the enterprise here, just out of curiosity, and it was like 2100 by 1500 pixels, and let's see, I'm looking for its size. This file size, yeah. So it's like, what is that, like? Pretty big. Again, when you're reading in an image that big, you need to do buffering, otherwise things. Anyway, so okay. So what I'm going to do is, since the slider goes from 0 to 200, and the idea is that each number is going to be the percent that it's being scaled by. So I'm going to multiply that by 100th. Okay, so here I'm going to get this is just a file object, connects to this. I probably should have checked to see whether or not it existed. If it didn't exist, then get all kind of errors. But again, the point of this isn't to well, I'll leave that to the disinterested reader. Okay, so here's image I/O. Like, the way the book does it, the way we used to have to do it, we had to kind of have all the buffering, all the stuff ourselves. But here I just give it a file, and it gives me back a buffered image. And then the only thing I have to worry about is an I/O exception, because if this is pointing to a non-existent thing, or if it's pointing to a file that isn't an image or a non-supported format, then it's going to throw an I/O exception. But if it succeeds in getting here, I get this buffered image. So here's how, now, because I want, even though the default is going to be 100, if somehow the default was something other than 100, I want to make sure it's scaled right to begin with. So, and actually, buffered image is a subclass of image, and image has a method called getScaledInstance. And what that does is that allows you to take an image, get another image. Now, it doesn't return a buffered image, but just a plain old image. But by this point, we don't really care, because an image is good enough. Why? Because the reason we want the buffered is to read the thing. So here, but every image knows how wide it is and how high it is. And so I'm scaling by the width, scaling by the height. I need to cast it to an int because the scale is a double. So, and then there are different, there are different options for this. I could make it fast. Here I wanted to make it smooth. So here now, for whatever reason, JLabels can't take an image. They require an icon. So if I have an image, I need to turn it into an icon. And fortunately, there's a class called ImageIcon, and I simply instantiate an image icon, give it an image, and then that returns an icon. And then now I can set the icon for the label. That's what, and then here I just wanted to set the title for that. So how does the state change work? So we basically do the same thing. So here, because I had the image icon, I could have gotten that from the JLabel as well, but so I get the height, get the width, and then I get the scale. In this particular case, there was like an issue because the scale went from 0 up. If I went all the way down to 0 and I tried to scale an image to 0, it doesn't like that. So what I said, okay, I'll get the value, but I'll get the maximum of that in 1. So if I've somehow gone all the way to 0, I'll at least give it 1, which will scale it by 1/100th. I get the scaled instance from the image icon. Okay, now, so the image, remember the image icon we instantiated with an image, and so I can get the image of the image icon and get the scaled instance of that, and then set the icon to that new scaled image. So I need to create a new image icon, pass it the scaled thing, and then I also update the status thing. So that's kind of what all this stuff did. Now, just see something I promised earlier, which was creates the standard label. So if I change this is the increment. So let's say if I change that to say 10, then that will show me an increment every 10 ticks, which is too many, as you can see. On the other hand, I could make it say 50. Okay, so it's the same thing there. Okay, so that's the J slider. That's how we can use it to manipulate images. That's how we can kind of read images from in this case, from a local file. Let's see, oops, no, modifications. Okay, so I want to go back to the 20. The 20 turned out to be the ideal one for me.
Sir, I have a quick question.
Sure.
So for the increments, if you put an odd number in there that doesn't meet to 200, does it just go just by the increments until it hits the max of 200 in this case?
Yeah, that's a good question. I'm not sure. Let's find out. Okay, I made it 17. And the answer is no. Yeah, so here it went to 187. So there. Yeah, and when you're kind of doing these, you want them to be sort of reasonable. I mean, this isn't a great user thing. Yes.
Instead of having the scale go from 0 to 200 and taking the max of 0 and 1, why don't you just start the scale at 1?
That's a good question, and that's actually what I did at first, but then the answer is laziness. Let me revert this here. Laziness. So if I were to make it 1, then when I kind of do the default here, as you can see, I get like kind of 21, 41, blah, 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 so it's like, now, I could have, I could fix this. But what it would require is that instead of like over here where I said create the standard labels with the increment, I'd have to kind of create the labels myself and put them all in, which I could do. But so laziness kind of just dictated it goes 0 to 200 and then kind of fix it when it gets to 0. But that was it was a choice, and that was actually the first thing I did. But then when I realized that I would have to kind of do all those things by hand, I said I don't want to do that. So, again, the virtue of laziness. Kind of, you know, because and if you're looking at a scale, you want the scale to be in round numbers typically, like this. Okay, so all right, now so now the next thing is that I want to show you how to unpack how to read the contents of a zip file. Now you in the last assignment you used the gzip file, and that was fairly straightforward because gzip is just takes a single file and compresses a single file. Zip, however, is both, is another dessert topping and a floor wax, where it's both a compressor and it's an archiver. In other words, as you've seen, like when you have a zip file, there's usually a bunch of stuff in there, right? So a gzip file can't do that. A gzip file can only take one file, and so when you with the movies thing, it was fairly straightforward because you unpacked it and there was just one file there, and if that file was the right thing, you could deal with it. With a zip file, you can't do that because a zip file may contain, some zip files only have one file, but most have more than one. So how do we deal with that? So that's just a little bit of extra stuff. Why? Because a lot of times the stuff we want comes in a zip file. Zip is probably the most common compressing and archiving format out there. You know why? Because like gzip and was kind of the older one, but when you wanted to do the same thing that zip did, you had to use another an archiver, which the Unix one was called TAR, which stands for tape archive, because that was used when you backed up your stuff to tape. I don't know if you remember tape, but they had these big reels of things, and then anyway, so just even these days with video, with streaming and everything like that, you still hear, they say, let's rewind that. Where does that term come from? How do you what does it mean to rewind a stream? Yeah, you literally had to rewind the tape. That's where that comes. Anyway, so okay, so that's it for today.